Hey guys, it's Rishi once again, and today we're going to be going through classes. And if you haven't seen any of our previous videos about functions, if and while loops, then please go ahead and click the link below where you'll be seeing a series of videos which will bring you up to the point where we are today. So what are we going to be covering in today's video? And that's going to be object-oriented programming. And that's one of the most effective approaches to writing software. And this is where we'll be writing classes that represent real-world things and situations. And you create objects based on these classes. So when you write a class, you're defining a general behavior that a whole category of objects can have. So that could be anything from having a class called dog, which we'll be creating, and then they may have certain behaviors like sit or roll over. So when you create individual objects from a class, each object is automatically equipped with the general behavior, and you can then give each object whatever unique trait you desire. And you'll be amazed with how well real-world situations can be modeled with object-oriented programming. So what will you learn in this chapter? Well, in this chapter, you'll write classes and you'll create instances of those classes. You'll then specify the kind of information that can be stored in instances, and you'll define actions that can be taken with these instances, before then going ahead and writing classes that extend the functionality of your existing classes, so similar classes can share code efficiently. Remember, all of the students that have reached out to me, I love that you're working hard, but now try to tailor that to working smart. Minimize your code. Try to make it more high level and efficient. And this is where we'll touch on our previous topic of modules and import classes, because we're going to be storing our classes in modules. And that way we'll be able to understand object-oriented programming to help to see the world as a programmer does. And it'll help you really understand your code, not just what's happening line by line, but also the bigger concepts behind it. So with that in mind, let's get started. Okay, wonderful. So in today's session, let's go ahead and talk about creating and using classes. So I've gone ahead and created my classes.py, and let's dive into this right away. Okay, so the first thing to understand here now is that we can model almost anything using classes. And let's start again by writing a simple class called dog, but not one dog in particular, but any dog. So what do we know about most pets? Well, we know they have a name and an age, and we also know that most dogs can sit and roll over. So those two pieces of information, which is name and age, and those two behaviors, sit and roll over, will go in our dog class because they're common to most dogs. And this class will tell Python how to make an object representing a dog. So let's go ahead and write that out. So we're going to start off with class dog. And remember here, we're now using our capital D for dog because it's a class. All this time I've been telling you to use lowercase for your variables, but now this is where you can differentiate. And within this dog class, we're going to store our name and an age. So again, before I go ahead and do that, let's go ahead and add our doc string. And we'll write a short message here. And now we can go ahead and define. So add in our function. And let's put in our init method. And I will be describing exactly what this does, followed by our parameters. So we've got self, name, as well as age. And you can see that name and age is not being highlighted. That's because it's not being accessed, as you can see here. Now that we've done that, we put our colon to tell Python to move to the next line. And let's go ahead and put another doc string outlining what this function is going to do. And then we're going to go ahead and call self.name. And we're going to equal this to name as well as self.age and equal that to age. So there's a lot to notice here, but don't worry. You'll soon see this structure throughout this chapter and you'll have a lot of time to get used to it. So in line 3, we've gone ahead and defined a class called dog. And by convention, the capital name is necessary because this refers to classes in Python. And the parentheses in the class definition are empty because we're creating the class from scratch. We then go ahead and write our doc string, which is simply describing our class. And then we move on to something new. Well, we know a function starts with our def, which is definition, but What is the init method? So now if I hover over this, it states it initializes the name and age attributes, which is what we can see here, but it also is a method and it's got the word self in there, self at dog. So what could this potentially be? Well, the init method is a function that's part of a class. And everything that you learned about within our previous chapter of functions applies to methods as well. The only practical difference for now is the way that we're going to be calling our methods. So this init method is a special method that Python runs, and it runs automatically whenever we create a new instance based on the dog class. And this method has two leading underscores. So again, at the beginning, as well two trailing underscores. And this is a convention that helps prevent Python's default method names from conflicting with your method names. And we define the init method to have three parameters, which is self, name, and age. And let's note here that the self parameter is simply required in the method definition, and it must come first before other parameters. And it must also be included in the definition, because when Python calls this init method later to create an instance of a dog, the method call will automatically pass that self argument. And every method call associated with a class automatically passes self. So what is self? I keep going on about it, but what is it? Well, self is a reference to the instance itself. It gives the individual instant access to the attributes and methods within its class. So when we make an instance of dog, Python is going to call the init method, and that's the initialize method from the dog class. And we're going to pass dog a name as well as an age as arguments. And this is where self comes in, because self is passed automatically, so we don't need to pass it. Whenever we want to make an instance from the dog class, we will have to provide the values for only the last two parameters, and that is name and age. So now the two variables defined each have a prefix, self, as you can see here on line 8 and 9. And any variable that is prefixed with self is available to every method in that class. And we'll also be able to access these variables through any instance created from that class, which is self.name equals name, because it's taking the value that's stored in the parameter name and storing it in the variable name, which is then attached to the instance that is being created. And the same process happens with self.age. So variables that are accessible through instances like this are called attributes. So now let's continue our programming. So let's go ahead and define two other methods, and that's going to be sit and roll over. So let's go ahead and write out our def sit, and we're going to call self with our doc string before writing out a print statement with a message. And we're going to concatenate this and say that the dog's name is now sitting, and as well as the same thing for our definition, which is rolling over. Now I'll go ahead and simply copy and paste this and paste it below. But this time, instead of sit, I'll go for roll over. Wonderful. So now the dog class has got two more methods. And because these methods don't need additional information like a name or an age, we're just defining them to have one parameter, which is self. And these instances we create later will have access to these methods. And in other words, they'll be able to sit and roll over. So for now, sit and roll over don't do much. As you can see, they're simply printing a message saying that the dog is sitting or rolling over. But the concept can be extended to realistic situations. So if this class were part of an actual computer game, these methods would contain code to make an animated dog sit and roll over. And if this class was written to control a robot, then these methods would direct movements that cause a dog robot to sit and roll over. So I hope you can see how we can go ahead and create a class and create our attributes within these. So let's go ahead and make an instance from a class. So think of a class as a set of instructions for how to make an instance. We have our class dog, which is our set of instructions, and it's telling Python how to make individual instances represent specific dogs. So let's go for my dog and let's declare a new variable. And we're going to capitalize our dog because we're going to be calling our class. You can see it's the same color as well, which is due to our syntax highlighting. And then we'll go ahead and define two arguments, one which is part of name and one which is part of age. Let's go with Nami and let's go with 6. Marvelous. And then we're going to go ahead and write a print statement, and that is my dog's name is followed by a concatenation. And then we'll write one out about my dog is this many years old. So the dog class that we're using here is the one we just wrote in our previous example. So what have we gone and done here? Well, we've gone ahead and we've created a dog whose name is Nami and is 6 years old. And when Python reads this line, it calls the init method in dog with the arguments Nami and 6. And so that init method creates an instance representing this particular dog and sets the name and age attributes using the values that we provided. So now please note that the init method has no explicit return statement, but Python automatically returns an instance representing this dog. And we store that instance in the variable myDog here. And the naming convention is helpful, and we can usually assume that a capitalized name like dog always refers to a class. And then the lowercase name like my_dog simply refers to a single instance that is created from a class. So that is how we go ahead and make an instance from a class. But now that we've got an instance, what about accessing our attributes like name and age? Well, to access the attributes of an instance, we use a dot notation. And so, as you can see here, in line 23 and 24, this is how we've accessed our attributes, by the dot in between my dog, which is our variable, and our attributes, which is age and name. And this syntax simply demonstrates how Python finds an attribute's value. So as you can see, here Python looks at my instance, my dog, and then finds the attribute name and age associated with my dog. And this is the same attribute referred to as self.name in the class. And you can see here self.name as well as in line 8 and 9. And then in the second print statement, it simply goes ahead and converts 6, the value of my dog's attribute, to a string because I've wrapped it. So let's now go ahead and talk about calling methods. So now after we create an instance from the class dog, we can use the dot notation to call any method defined in dog. So let's go ahead and make our dog sit and roll over. So I'm going to call my dog here, and I'm going to go ahead and call the function sit, as well as my dog again, and this time roll over. So to call a method, what have we done? We've given the name of the instance, in this case it was my dog, and the method that you want to call separated by a dot. So when Python reads mydog.sit, it looks for the method sit in the class dog and it runs that code. And then Python interprets the line mydog.rollover in the same way. So now if we go ahead and print this out, let's see what our output is. Amazing. And we can now see my dog's name is Nami, my dog is 6 years old, Nami is now sitting, and Nami rolled over. So this syntax is quite useful because when attributes and methods have been given appropriately descriptive names like name, age, sit, and roll over, we can easily infer what a block of code is doing. So I hope that was a clear example as to how we can go about making a class, making an instance from a class, and then accessing those attributes and calling those methods. But let's think about the efficiency here. Let's imagine we need to call multiple instances of this. How can we simply go ahead and create those multiple instances? Well, we can create as many instances from a class as we need. So let's create a second dog called your dog. So again, I'm going to simply go ahead and write out your_dog equals dog. Again, as you can see, that's in capitals. And let's assign it to 2 arguments here. And we'll go for Leo and the age 3. We're then going to go ahead and copy out the 2 print statements and make changes to these. Instead of my dog, we'll go for your dog. And we'll also change this within our statement here. And then we need to call our method. So we can go for yourdog.sit. So now having done that, we can now see how we've simply gone ahead and created a dog named Leo, and set it to the age of 3. And because each dog is a separate instance with its own set of attributes, they are also capable of the same set of actions. So what should our output be? Well, it should be your dog's name is Leo, your dog is 3 years old, and Leo is now sitting. So let's go ahead and print this out. And you can now see we've got your dog's name is Leo, your dog is 3 years old, and Leo is now sitting. So even if we use the same name and age for the second dog, Python would still create a separate instance from the dog class. And you can make as many instances from one class as you need, as long as you give each instance a unique variable name, or it occupies a unique spot in a list or a dictionary. So again, for a new instance, what do we need to do? We need to go ahead and make an instance from a class, which we've done in line 31, followed by our print statements, and then finally calling our method as we learnt in our previous chapter. Wonderful. So this brings me to the end of our first section, and I've got 3 programs that I would like you to dive into. So please go ahead and pause the screen now, where you'll be given these programs in light of what we've just covered now. Take your time. I hope you're enjoying our course. Press play when you're ready to go through the solutions. Welcome back. I hope those 3 programs gave you a clear insight how to use the init method as well as writing your own classes. So let's now jump into creating a new file, which is going to be chapter8solutions.py. So let's go ahead and create a new file here. That's going to be chapter8solutions.py. Right, so let's dive into this. So restaurants, that's our topic. We're going to make a class called restaurant, and the init method for restaurant should store 2 attributes, which is the restaurant name and a cuisine type. So let's go ahead and write our class restaurant with our empty braces, and let's go ahead and put in our doc string, which is going to be a class representing a restaurant. So now we've done that, let's go ahead and define our method. So definition followed by our init method, and we'll call self with the 2 attributes, which is a restaurant's name and its cuisine type. And within that, let's go for another doc string, and that's simply going to allow us to initialize our restaurant. And then let's go ahead and call our self.name prefix. And this is going to follow all of our parameters, and you can see now the name has become a light blue, and we're going to do the same thing for our cuisine type. And you can now see that has changed color as well. Marvelous. It then states that we need to make a method called describeRestaurant that prints these 2 pieces of information, and a method called openRestaurant that prints a message indicating that the restaurant is open. So that now means that we need to have 2 more functions, which is describeRestaurant and openRestaurant. So let's go ahead and write that out. So let's go with our define describe_restaurant. And again, we'll take 1 parameter, which is self. We'll then go and put our doc string in place. And I know it can be tedious at times, but make sure you follow this structure because it will benefit you in the long run when you come back to your code and you want to understand what it does. And then let's go for a message, and we use our format method as well for this, where we have our placeholder. Before simply printing this out. Go for our /n for our new line, followed by message in our placeholder. And we'll do the same exact thing, but this time for openRestaurant. And again, don't forget our doc string. Marvelous. So now we've gone ahead and written that out. We then need to make an instance called restaurant. So let's go ahead and do that. So this will be outside of our functions. So let's go ahead and write restaurant equals, and then we're going to call our restaurant class, which is again going to be capitalized, and we're going to provide our arguments. So let's go with a name of a pizza as well as a cuisine type. So let's go for the Mean Queen as our restaurant name, and our cuisine type will be pizza. So now we've gone ahead and done that. Let's go ahead and print our restaurant name using our dot method, and also our cuisine type. Marvelous. And we'll do the same thing for our describe restaurant. And now we need to print out a method called open restaurant that simply prints the message indicating that the restaurant is open. So again, let's go ahead and call restaurant.describe restaurant as well as restaurant.open restaurant. And let's go ahead and run this. And we can now see we've got the Mean Queen pizza. We've got the Mean Queen serves wonderful pizza and the Mean Queen is open. Come on in. So I hope that was now clear how we can go ahead and make a class called restaurant. We have our init method, which has two attributes, a restaurant name and cuisine type. And we've made two methods, one which is describe restaurant and one which is open restaurant. And that prints out two pieces of information. And then finally, we've gone ahead and made an instance called restaurant from our class and printed two attributes individually. And then finally calling both methods at the end of that. Okay, let's now move into 8.2. And this is now where we need to start with our class from our previous exercise and just simply create three different instances from the class and call describe restaurant from each instance. So I'm going to write just beneath this, and we're going to go ahead and create three more instances just the way we did for our restaurant equals restaurant, the Mean Queen and pizza. So let's go ahead and write one out, which is going to be Indian Mahal equals, let's go for our restaurant, which is our class name, followed by our arguments. So let's go for our restaurant name, which is going to be Indian Mahal, and our second argument, which is going to be Indian, and that's the Indian food. We're then going to go ahead and call this using our dot notation. So we'll go for Indian Mahal dot describe restaurant, and we're now calling that. And we can do the same thing with Indian Mahal dot open restaurant, and we need to do the same thing. So I'm going to go ahead and copy out these two so I can paste it when I go for my third one. That's going to be Taki, and let's call our restaurant here. Let's go for Taki, followed by Japanese, and then we'll go ahead and change that each one to Taki when calling our describe restaurant and open restaurant method. So now I've gone ahead and I've written out two more, and let's go ahead and run this and see if we get the same information. Marvelous. And you can now see we've got Indian Mahal serves wonderful Indian. Indian Mahal is open, come on in. And we've got the same for Taki serves wonderful Japanese. Taki is open, come on in. So I hope that was now clear and how you can call multiple instances in a matter of minutes. Okay, let's go for the final one. And this is where we need to make a class called user and create two attributes called first name and last name. So let's go ahead and write that out. We'll put our docstring in place. And let's go ahead and create our two attributes, first and last name, and then create several other attributes that are typically stored in our user profile. So let's go for our init method. We'll call self as our first parameter, followed by first underscore name. So again, if it's more than one word, I'm using my underscore. Don't forget our docstring once again. And let's go ahead and set a variable to each and every one of these parameters. Marvelous. So we've gone ahead and created our attributes. We're now going to make a method called describe user that prints a summary of the user's information. And then we'll go ahead and make another method called greet user that sends out a personalized greeting to that user. And let's go ahead and add our 4 print statements. And I'll simply go ahead and paste these out. And again, as you can see, I've used my F format method, which again uses my placeholders with self.firstname, last name, username, email, and location. And then I'll go ahead and add one more method, which is to greet the user. And then I'll add one more method, which will then create a personalized message for each user. And that will be greet user self. And again, our docstring before we put in our print statement. Again, I'll put that on a new line. We'll say welcome back. And then if we go up, and we need to create several instances representing different users and call both methods for each user. So now I'm going to go ahead and write out a name, Rishi, and we'll go with our users class. And this is where I'll be adding in all of my arguments. So let's go with Rishi as our first name, Bagger as our surname, our email as, and our location as London. And then we need to go ahead and call our two methods, describe user and greet user. So again, that's going to be done through our dot notation. And I'll go ahead and do one more, and we'll name this lyric. And then again, we'll call lyric once more. And there we have it. So again, as you can see, we've now gone ahead and created two attributes called first name and last name, and we've added our own attributes that could be typically stored in a user profile. We've then gone ahead and created a method called describe user that prints out a summary of the user's information, as well as a greet user, which displays a personalized message to the user, before going ahead and creating several instances representing different users and calling both methods for each user. So let's now go ahead and print this out and see what we get. And we've got an error, and that's a type error. And so now it's missing one required positional argument. So let's take a look at that here, and that's in line 77. So again, we've got our first name, last name, and we're missing our username on both of these. So as you can see now that it's sending across a type error, noting that our positional argument is being missed by one. So let's go ahead, and you can see it states location. And the reason it's stating location is because it's taking the email as our username and then our London as our email. So again, let's go ahead and add a username. And let's do the same for lyric here. Wonderful. And let's go ahead and print this out. And we can now see we're getting Rishi Bagger as our name. We've got a username, email, and location. And we've got a personalized message saying welcome back, followed by my username. And that again is being done in line 75. And then we've got the same thing for our second user, which is Lyric Williams. So as you can see, this is now using our real world like scenarios to present output that is relevant to the user. I hope those three programs were now clear. Let's go ahead and jump back into our classes.py, where we will be talking more about working with classes and instances. So you can use classes to represent many real-world situations like I've just shown you. And once you write a class, you'll spend most of your time working with instances created from that class. And one of the first tasks that you want to do is simply modify the attributes that are associated with a particular instance. And you can modify the attributes of an instance directly, or write methods that update the attributes in specific ways. So let's take a look at a new class, and that's going to be my car class. So what I'm going to do is simply go ahead and comment everything out. And let's talk about a new class that represents a car. And that class is going to store information about the kind of car that we're working with. And it will have a method that summarizes this information. So again, let's go ahead and write out our new class. Don't forget your docstring. And let's go ahead and define our init method. And remember to use self. And this time we're going to go for our make, model, and year as our parameters. And you can see again that they are not being accessed, so the color is not being highlighted. But now we're going to initialize the attributes to describe the car. Marvelous. And then let's go ahead and write out a method which will get the descriptive name. And we need to return that name. Let's go for long name, and we're going to wrap this in a string function, as we're going to be working with different data types such as an integer. We'll go ahead and concatenate this and give it a space. We're doing self.make and concatenating again, and then self.model before simply returning our long name. and we'll put a title in there as well. And then let's go ahead and call this out before printing out our new car as well as the descriptive name. So let's go ahead and go through what we've written out. So firstly, we've gone ahead and written out our car class, and we've defined our init method with the self parameter first, just like we did before with our dog class. We also gave it 3 other parameters, which is our make, model, and our year. And the init method takes in these parameters and stores them in the attributes that will be associated with instances made from this class. And when we make a new car instance, we'll need to specify a make, a model, and a year. And then we go ahead and define a method, which is getDescriptiveName. And that puts a car's year, make, and model into one string, neatly describing the car. And this will spare us from having to print each attribute's value individually. So to work with the attribute's value in this method, we use self.make, self.model, and self.year. And then we finally go ahead and make an instance from the car class and store it in the variable myNewCar before printing it out, and we will get our descriptive name alongside that. So let's go ahead and print this out. And we can now see we've got 2016 Audi A4, and that's all in our title case. So to make this class more interesting, let's add an attribute that changes over time. And we'll add an attribute that stores the car's overall mileage. And this is where we need to go ahead and set off by setting a default value for an attribute. So now every attribute in a class needs an initial value, even if that value is 0 or an empty string. And in some cases, such as when setting a default value, it makes sense to specify this initial value in the body of the init method. And if you do this for an attribute, you don't have to include a parameter for that attribute. So let's go ahead and see what I mean here. So I'm going to go ahead and start off by writing self.odometer. And I'm going to equal this to 0. And as I mentioned, by doing this, we don't have to include a parameter for that attribute. And let's also go ahead and add a method, readOdometer, that helps us read each car's odometer. And that again means I need to write out a new method here. And let's put in a print statement, which just showcases a short message to this, outlining the mileage of the car. And again, we need to wrap it around a str as we're working with a different data type. And let's go for miles on it. So now this time, when Python calls the init method to create a new instance, it stores not only the make, model, and year value as an attribute, as a previous example, but now it's going to create a new attribute called odometer reading, and it's going to set its initial value to 0. And again, we have a new method here as well called readOdometer, and it makes it easier to read that car's mileage. And before we go ahead and print this out, let's go ahead and call our method. So I'll go for myNewCar.readOdometer. And let's go ahead and print this out. And we can now see we've got 2016 Audi A4, and this car has 0 miles on it. So not many cars are sold with exactly 0 miles on the odometer. So we need a way to change the value of this attribute. So let's think about how we can go ahead and modify the attribute value. So let me go ahead and paste this out in this section here, at the end of this line. And let's go about modifying our attribute value. So now there are 3 different ways that I'm going to be showing you how to change an attribute's value. Now, number 1, you can go ahead and change the value directly through an instance, or you can set the value through a method, or finally, you could increment the value and add a certain amount to it through a method. So let's look at each of these approaches. So the simplest way to modify the value of an attribute is to simply access it directly. So let's go ahead and write that out. Let's go for myNewCar, and let's call our odometer reading, and let's make this equal to 23. And then we're going to call myNewCar again, and we're going to read the odometer. And we can simply go ahead and print this out. And you can now see it's got the car has 23 miles on it. So again, just a quick reminder, we've used our dot notation to access the car's odometer reading. and then we've set its value directly. And this just tells Python to take the instance of my new car and find the attribute of odometer reading associated with it. And sometimes you'll want to access attributes directly like this, but other times you'll want to write a method that updates the value for me. So let's go ahead and go for our second method, which is modifying an attribute's value through a method. So now it can be helpful to have methods that update certain attributes for you. And instead of accessing the attribute directly, you pass the new value to a method that handles the updating internally. So again, we can go ahead and write a method which is update odometer, and we'll take mileage as our first and only parameter. We'll go ahead and add our doc string, which is again to set the odometer reading to the given value. And then we'll go ahead and call our self odometer reading, and we'll set this to a variable mileage. And you can now see that's been done with our prefix. And now this time when we're calling our instance, we're simply going to go with my new car, and we're going to update our odometer. And then we're going to call our my new car again, and it's going to be to read the odometer. So now the only modifications to car is the addition of the update underscore odometer. And this method is simply taking in the mileage value and storing it in self odometer. And then we go ahead and call the update odometer and give it 23 as an argument, which is then corresponding to the mileage parameter in our method definition. And then it sets the odometer reading to 23, and it reads the odometer, printing that reading out. And then again, I won't print this out right away because this will give me an error as I haven't put it in the right location. It should be within my methods location here. So let's go ahead and move this and indent these. And then let's go ahead and clear my terminal and print this out. And we should now be able to see that the car has 23 miles on it. So again, as you can see, I'll copy this and I'll paste it back again here, just so you can see how this can be done. And then I will comment this part out. Okay, wonderful. And let's move on to our third and final way. And what we can do here is now go ahead and extend the method update odometer to do additional work every time the odometer reading is modified. So we're going to add a little logic here to make sure that no one tries to roll back the odometer reading. So within our update odometer, we're going to go ahead and code in this section here. And again, I'm going to take the same method here, paste it beneath, and let's add in our doc string. So let's put in our if statement. So we'll say if mileage is greater than or equal to self.odometer reading, and we can put in the same line as what we had here, just beneath that. It will now read out our self-odometer reading, which is our mileage. Else, we'll go ahead and print a message which says you can't roll back the odometer. So now update odometer checks that the new reading makes sense before modifying the attribute. And if the new mileage is greater than or equal to the existing mileage, self.odometer reading, then you can update the odometer reading to the new mileage. However, if the new mileage is less than the existing mileage, then you'll get a warning that you can't roll back the odometer. So again, let me go ahead and comment that out, and let's print this. And we can now see that this is being printed out. But let's go ahead and test this, and let's put a number that is less than 23. So let's go ahead and test this out to see if this really is working. So let me go ahead and clear my terminal, and let's go below and change our update odometer to 22, and let's print this out. And it says you can't roll back the odometer. So you can now see this is working in both cases. So again, if the mileage is greater than self odometer, then that's absolutely fine. It'll go ahead and assign that. Otherwise, it'll print out a message saying you can't roll back the odometer. So I hope those three methods were now clear. Let's move on and talk about how we can go ahead and increment an attribute's value through a method. So let's take a scenario here. Sometimes you'll want to increment an attribute's value by a certain amount rather than set an entirely new value. So let's say we buy a used car and put 100 miles on it between the time we buy it and the time we register it. Now let's take a look at a method that allows us to pass this incremental amount and add that value to the odometer reading. So here's a method that I've written previously that allows us to pass this incremental amount and add that value to the odometer reading. So what's happened here? Well, the new method increment odometer takes in a number of miles and adds this value to the self odometer reading. And that again is in line 96. And then we go ahead and create a used car. And we set its odometer to 23,500 by calling update odometer and passing it 23,500. And then we go ahead and increment the odometer and pass it to 100 to add the 100 miles that we drove between buying the car and registering it. So we can go ahead and edit all of this out, remove our class car, and paste it just below this here. Make sure we indent everything and it's all in place. And I'll also go ahead and take this line and put it at the top of here so we can see that we're incrementing an attribute's value through a method. And let's go ahead and run this. And we should now be able to see this car has 23,500 miles on it and then 23,600 as we've gone ahead and incremented it by 100. And that's just again by putting our value as an argument. So please remember that you can easily modify this method to reject negative increments so no one uses this function to roll back an odometer as I've shown you previously. And you can use methods like this to control how users of your program update values, but anyone with access to the program can set an odometer reading to any value by accessing the attribute directly. Okay, this brings us to the end of our second section, and I've now got 2 programs that I would like you to dive into. So go ahead and pause the video here, attempt those programs, and press play when you're ready. Keep up the great work. Welcome back. Okay guys, let's now dive into our Chapter 8 Solutions folder, where we will be going through the 2 programs that I have listed out. The first program is going to start off with our program from exercise 8.1, and we need to add an attribute called number served with the default value 0. So before I dive into this, I'm going to go ahead and copy out my program from 8.1, and I'm going to take this section of the program first and just paste it below here. I'm then going to go ahead and comment out everything else so it doesn't give us unexpected results. Wonderful. It then asks us to add a method called setNumberServed and lets you set the number of customers that have been served, and then we're going to call that method with a new number and print the value again. So let's go ahead and dive into that first. So let's go for define setNumberServed, and I'm going to take 2 parameters, one which is self and one which is number_served. Now that I have that, let's go ahead and add our doc string, which is going to be allow the user to set the number of customers that have been served. And then I'm going to go ahead and initialize this. So I'm going to go self.number served equals number served. And then if we scroll up, it asks us to add another method called increment number served. And what this is going to do is simply let you increment the number of customers who have been served. So let's go ahead and write that out. So I'm going to go with increment underscore number underscore served. And I'm going to go ahead and write up my 2 parameters, one which is self and one which is additional underscore served. And then we go ahead and write our doc string, and this is again allowing the users to increment the number of customers served. Before going ahead and initializing this, so self.number underscore served, and we're going to add an increment to this, so plus equals additional served. And now that is done, I'm going to simply go ahead and call both methods setNumberServed and incrementNumberServed. So let's go ahead and write this out below here. And again, I'm going to go ahead with my print statement. I'm going to go with the format method, line, and write out number served with my placeholder, which is going to hold my restaurant dot number served. And again, I'm going to set a value to this. and I'm going to equal it to 430. And then finally printing out one more statement, which is going to give me my new value here. Again, I use my dot notation, and that's number served. I'm then going to go ahead and copy out my first two lines and paste this below here, but this time I'm going to change the value here and then put the print statement just below before finally doing the third statement, which is going to be calling our increment number served method. So let's go ahead and call that here, and I'll put in 239, and that will be incremented to our previous value in line 136. And let's go ahead and print that out. So let's call our restaurant and our number served. So let's go through this one more time. So what have we done? We've started with our program from exercise 8.1, and we've gone ahead and added an attribute called number served, and that's got a default value of 0. And then we've gone ahead and created an instance called restaurant from this class, and we're printing the number of customers that the restaurant has served, and that is simply below here on line 133 and 134. We've then gone ahead and added a method called set number served that lets you set the number of customers that have been served. That lets you then call this method with a new number and print that value once again. And then I've gone ahead and added another method, which is increment number served, which lets you increment the number of customers who've been served. And then we've called that method with any number that we like, which we've stated in line 136. So let's go ahead and clear our terminal and then run our program. And there we are. You can now see that we have the number served 0, which is our default value that we had set. We've then gone ahead and stated that it's served 430 people. We've then changed that to 1,257, and then finally incremented 239 to that, which gives us 1,496. So I hope that was clear. Let's now move into our second challenge, which is login attempts. So within this program, we now need to add an attribute called login attempts to our user class from exercise 8.3. So what I'm going to simply do is go ahead and comment out this program here and work with the program from 8.3. And let's go ahead and add an attribute called login attempts. And alongside that, we will write a method called increment login attempt that increments the value of login attempts by 1. So the first thing I will do is go ahead and write myself dot login attempts, and I'll equal this to 0. And remember, once again, as this is my default value, I do not need to put this as part of my parameters. The next thing I'm going to simply do is go ahead and create a method. So I'll go ahead and do that beneath my Greek user. So let's go with increment login attempts, and let's take self as a parameter. We're then going to go ahead and add our doc string, and that's simply going to increment the value of login attempts before going ahead and incrementing this. So again, we'll call our self.login attempts, and we'll increment this by 1. Let's not forget to indent this. And now that is done, let's scroll back up and go to the second part of this program. And that is where we need to make an instance of the user class and call the increment login attempt several times, and then print the value of login attempts to make sure it was incremented properly, and then call the reset login attempts before printing that out again. And that again, we can test to make sure it resets to 0. So we've now gone ahead and set our method, which is the increment login attempts. Let's go ahead and print out an instance. So we're making 3 login attempts, and then we'll have one at the end, which is reset those login attempts. Just beneath Rishi, let's go ahead and remove lyric for now. Let's go ahead and add in a print statement. Let's go ahead and add a new line, and let's go for making 3 login attempts. We'll then go ahead and call our user, and I'm going to call my method increment login attempts, and I'll do this 3 times before finally printing out a statement with the number of login attempts that we have done. And then let's go for our final part, and that is where we're going to be resetting. So it states print the value of login attempts to make sure it was incremented properly, which is what we've just done now, and then call the reset login attempts and print those login attempts again to make sure it was reset to 0. So let's go ahead and do that now. So let's go for our print statement and let's write down that we are resetting login attempts. Let's call our user Rishi, followed by login attempts, and then a print statement just below that where we go for our login attempts. And this time, this is going to allow us to see what our login attempts are now after we've gone ahead and reset them. So what should we see here? Well, we should see our user Rishi, followed by his username, his email, his location, as well as a message greeting him. Thereafter, we should see a print statement which states out making 3 attempts, as well as the number of attempts that Rishi has made. And as we've printed this out 3 times, the answer should be a number 3. Before then going ahead and resetting the login attempts, and if we reset them, that 3 will now drop down to a 0. And let's go ahead and clear our terminal and then print this out. And you should now be able to see Rishi Bagga and his user information, followed by a greeting message, and then the 3 login attempts, which we can see, and then resetting those login attempts, which then brings it back to 0. So let's go through and see what we've changed here. We started off with changed here. So we started off with our user class. We took a series of parameters. First, we had first name and last name, and we added 3 more. We then went ahead and again and initialized another method. We then initialized another section where we had login attempts and set this to 0. And again, because this was a default value, we don't need to put it as part of our parameters. We then added on 2 methods. The first one was incrementing the login attempt by 1, and then resetting that login attempt to 0, before finally calling our method using our dot notation, and then printing the value of login attempts to make sure that it was incremented properly before finally resetting it. So I hope that was now clear, and I hope you would now feel more comfortable in making functions and also calling your instances as well as your methods. So this now brings us to the end of our first section of classes. In this part, you learned how to write your own classes. You learned how to store information in a class using your attributes and how to write methods that give your class the behavior they need. And you also learned to write the init method that create instances from your classes with exactly the attributes that you want. And then finally going through and modifying the attributes in an instance directly and through methods. So now in the next section of classes, we're going to be learning about inheritance, where you can simplify the creation of classes that are related to each other. And you can also learn to use instances of one class as attributes in another class to keep each class simple. So don't forget to go through your code once again, just to understand exactly what you're doing and how each section of the code is linked with one another. See you in the next video.